Great, thanks a lot. Hi, everybody. I'm Roy. As I mentioned, I'm from Israel. I do C++ for a long time now. I work for a company called Isra Research, which does algorithmic trading. And before starting, I do want to mention this COVID crisis that we're all in. Happily, during the last month, there have been, good announcements regarding vaccines and stuff, but still things are shaky here in Israel, and I understand that in Europe as well. There's a lot of tough situations. So really, my heart is with you. I hope good health to all of you. And this should hopefully be a nice pastime among inside this stress, I guess. Okay, and the next piece of disclaimer is that I program in C++ a lot, and I dive pretty deep into things. But in the topic that I'm about to talk today, I'm not an expert. I'm just a dude. This is a quote from Scott Shore from CVPCon 2015. I'm not the first one to re-quote him. I think some people know this. So feel free to correct me. Feel free to criticize me. This is all just a learning experience for all of us. Okay, so into the meat of the matter. My main topic today is C++ core guideline F16. I assume many of you know the core guidelines. They're an official list of suggestions and ideas on how to write a good C++ code. It was initiated by Herb Sutter and Bjarne Strastrup. And the rule F16, of course, is about passing parameters, specifically passing in parameters or input parameters into functions. And the guideline basically says that cheaply copied types should be passed by value and others by reference to const. And this is all sounds very nice and very simple and quite trivial to all of us, but it's not so trivial because we always we write a lot of functions in our day-to-day job. In parameters are the most common ones, and suddenly we need to think about cheaply copied and what's cheaply copied and what isn't. And because the guideline basically gives us two approaches that we can use, we need to choose one of them. In terms of the reasoning inside the guideline itself, it basically just tries to tell us why both options are valid without much discussion of which one to choose. But if we read along, the guideline does go and discuss this notion of cheap to copy. And it tells us that it is sometimes important to make this distinction and not just go with one of the options all the time. Because when copying is cheap, it can mean simplicity, safety, and it can make our code faster. So, all these three together means that we might want to pay attention, might want to think about these things as much as possible. Okay. Earlier this year in February, in the C++ meetup Prague, Herb Sutter, the chairman of the ISO committee, who's also one of the initiators of the guidelines, also had a nice and long talk about argument passing. He basically told us about these accidental complexities of the language, where these things that are so very common to our day-to-day are so complex to explain, so complex to understand. And this first top line in the table basically says in black all the guideline that we talked about so far. And in his talk, Herb tries to give his vision towards a newer version of the language where things will be simpler. But here we are still in 2020, and in this talk, I'll try to see how to deal with this guideline as it is right now. So first of all, a few examples. Here you can see 4 small functions that I wrote down that are very, very similar to each other. They all take one vector by reference and one object, and they basically iterate through the vector. It's one might call this a row loop. It's very similar to a transform, but I think the notion can be discussed or described with a for loop or with a transform in the same manner. But basically, you can see that as we move from the primitive type to maybe a small 2D or 3D point into more complicated matrices or strings, the copying becomes less and less cheap, more and more of an issue. And at some point, we need to break to cut the line and move from pass by value into pass by reference. And This is all very nice and good, and that's what the guideline tells us. As you can see, these 4 functions are all very, very similar. They can all be expressed in a similar manner. And as you mentioned, even the STL has algorithms that try to generalize these 4 things into one. And the main question that I'll try to answer in the end of the talk is what should we do about templates? Okay, so we have a template function, such as this apply function, a very small alteration on the transform, where we basically take a container by reference, take a value and a binary operation, and we go and apply the operation one by one on all the items. And again, we can either implement it with pass by value or with pass by const reference. But the question is, how do we do both? How do we make this template function work according to the guidelines? And one of the last slides of this talk will try and give a suggestion of a way to do it using things in the language. Before we go there, I want to talk a little bit about how it's currently done usually in STL and other template libraries. Okay, so the most typical approach for template functions right now is to just pass by const reference. Okay, here are 2 canonical examples. Here's the operator paren of std plus, as well as the remove algorithm from the algorithm header. You can see that they take their t arguments as const t reference. I think it might make sense that this is a reasonable default. As we know, pass by value, it can be cheap, it can be expensive as well, depending on the type, whereas pass by reference seems to always be cheap. So if we're not sure, it seems like pass by reference is a good default. On the other hand, there are some examples, even in the STL, where they chose to take things by value. One such example is the accumulate function. In the accumulate function, we actually take a t object as an argument, and we also return a t object, which is the same value after having been through some manipulations. So this choice of taking t by value and then manipulating it itself seems to make sense. We need to make a copy anyway, so let's have the language make the copy for us. And another case where we choose to take things by value is the std bind function. Okay, std bind is sort of like poor man's closure for lambdas. It was added in C++11 together with lambdas, but some variations of it existed or could have existed even before C++11. And there we can take an argument such as this a argument here and keep it inside the closure. And for object lifetime and safety reasons, the choice was to keep it by value. Okay, so this transform, by the way, is an implementation of one of the functions that I showed as an example before, where we go and scale down all the members of, I guess, the sequence V by an item A. We can see how that can be implemented with a transform and a bind, and the bind takes this as a pass by value. Okay, before we move on, I do want to talk about the elephant in the room regarding the difference between passing things by value and reference. And before we move to that elephant, I think this might be a good time to stop for questions in case there are any. Okay, so I assume no questions. So let's move on. So the elephant in the room is aliasing. Okay, I don't know how many of you have heard about it, but it's quite, I guess, quite an important topic to talk about, to know about. And the main thing about aliasing is the fact that when we pass things by reference, especially reference to const, the fact that the reference is const doesn't mean that the object itself is const. Okay, so here's a nice example of this whole thing. If we call a scale down function, in this implementation, I chose to use const reference, and I go over the vector v, and item by item, I go and apply this division operation. If I go ahead and call scale down with a specific vector or sequence and passes the argument a one of the members of that same vector, I get what's called as aliasing. I get these two references. One can be, in this case, one is const, the other is not const, to the same object. Okay, and as I go inside the for loop and update the vector, inadvertently the a argument gets changed as well, and this is all fully legal in C++. This is something that the compiler not only is allowed, it actually has to do and has to live by. And that means that if I run this code as it is, all that happens is the first element of the vector or the container will get divided by itself, and I assume be converted to 1, but then all the other elements will just get divided by 1. And this is clearly not what we wanted. And this is a good example where aliasing is really important for the functional behavior of our code. Just taking a function that takes an argument by value and changing it to const reference or the other way around is something that actually changes the semantics, changes the behavior of our code, and we need to think about it. This is many times quite rare, but still, if you write especially generic code, we need to think about it. Not only does aliasing have implication on the functionality, it also has a lot of implications on performance. As we mentioned, the compilers need to always think about aliasing, and when they optimize their code and convert C++ code into assembly, whenever there are references in play, compilers need to consider whether there's any risk of aliasing. And in fact, a lot of the optimizers' work goes into trying to understand whether there is risk of aliasing or not. And whenever there's a risk, the compiler needs to dial down on a lot of optimizations, which can really hurt us. It's harder for the compiler to rely on registers instead of memory addresses, because again, if I move things to registers, suddenly they don't have addresses, they cannot alias, or things cannot alias inside registers. And similarly, when it comes to vectorization, either the MMX or XMM types of vectorization, and obviously, of course, GPU types of vectorizations and loop unrolling are also things that are harder to do when aliasing comes into play. And we need to consider the fact that as we iterate through an array or as we iterate through a set of objects and change them, we might inadvertently change one of the const reference objects that we're also working with, and need to make sure that these updates haven't happened and correct accordingly. So this aliasing thing is quite important and quite tricky, and it means that passing things by const reference is not as cheap as we might think it is, especially when it's inside the critical path of our code. So before thinking about how to work with it and what to do about it, just by trying to move away a little bit and look at things not from the library or function implementer's perspective, but from the caller's perspective, I wanted to mention that if you find yourself using a function, either in the STL or with any library that you want, that has the incorrect semantics from your point of view, you can always go ahead and try and enforce it into the semantics or the scheme that you want. Okay, so this is one example of such a forcing. I guess many of you have heard of the erase remove idiom, by which if one wants, especially before C++20, to remove elements from a container, they need to call the remove algorithm and then follow it by reverse. But this similar idiom is something that maybe some of you do not know, which is the way or the correct way to remove the maximum element from a container. Okay, if I have a container with many elements, I want to remove the maximum elements. And in case of repeating maximum elements, I want to remove all of them. And we need to call remove on erase on the max element. But the tricky part here is that max element returns an iterator into the array. So if I go and use operator star on that, I will get aliasing. Okay, I will get a reference or a const reference inside the array. And if I do not go ahead and convert this const reference into something that is not aliased, I will suffer. Okay, and the code will not do what I expected. Okay, and this decal type vec : value type is just a way to basically tell the compiler, hey, create this temporary object, copy whatever the const reference is to another object, and pass that into remove, just in order to avoid this risk, which is very, very real in this idiom of aliasing. Okay, going the other way around from a function that expects or does pass by value and making it work by reference semantics is also possible, usually. And the common way to do it is using std : ref utility function and the std : reference wrapper class. I think there are some good talks in CPPCon discussing that class. And basically, this wrapper class is a very small object in the size of a pointer that is cheaply copyable, but has conversion operators which make it seem like it's a reference to an object. So passing this std_ref by value makes it actually has the behavior of working by reference. And this is also an interesting thing to be aware of. It's not as simple and as easy as the bullet above. It's more delicate. Some template functions that should accept any T will not work out of the box with the reference wrappers. So your mileage may vary. And if you write your own template algorithms and expect to receive arguments by value, I suggest or recommend that you try out to see whether your algorithms also work with the reference wrappers as well and give some adequate results. Okay, so that's that. And now we're at the point where we can go back and talk about the way to implement our own template functions that are conforming to the C++ core guideline in C++ 20 in a way that's allowed and that makes sense. And happily, a few months after Herb's talk in February, he gave a very similar talk on CPPCon in September. And on that talk, he also gave me a hand and showed us his approach to implementing the core guideline by himself, both in the current language and in the new language. Let's skip to the next slide and see it in a little larger format. And this is what Herb suggested, so to speak. And basically, it revolves around a predicate called the should pass by value v. Okay, this predicate is something that Herb mentioned. It can be defined in many ways. He didn't give a lot of thought, or at least that's what he said about this specific formula that he chose. But I assume that he wrote it down and told it to all of us because he thought it's relatively good. And using that and the C++ requires clause that comes with the concept, with the whole notion of concepts in C++ 20, gives us the ability to take the two functions, template functions that we wrote earlier, one that accepts arguments by value and another by const reference, and give the compiler a way to let them coexist and choose which one to use with which type. Okay, so the requires clause is used here to basically differentiate and choose which of the two alternatives to use. And this basically is a good way to, I guess, adhere to the core guideline that we wrote and we talked about earlier. When I look at this code, I have various things that I think about and various comments that come to mind. I assume that you also might have some thoughts about that and maybe about other things. So maybe this is a good time for another question break, if there are any questions.
No questions at the moment.
Okay, good, great. So here are things that I thought about as I read this code. First of all, this is clearly C++ 20 code. It uses the requires clause. And in here, Herb Sutter decided to implement the should pass by value v construct as a context for bool and not as a concept. Okay, if any of you who know concepts know that this is a very subtle difference, right? Concepts can basically model any context for bool quite easily, and here the decision was to use context for bool and not a concept. This was very fishy to me. I really couldn't say why this was, whether it's just because Herb didn't want to overburden the listeners with yet another keyword, or was it something, was there more to it? I can tell you that on tomorrow's talk on Core CPP that is devoted more towards concepts, I will devote some more time into this topic and try to give us a little bit of guidance, a little bit of tips or perspectives on when to use a concept and when to just go for a context or bool or other types of predicates. The second thing that I thought about was the specific condition that was chosen. Is trivially copyable v and n size of t smaller than 8. It's a condition. Herb Sutter himself said that any predicate could work here. But what will make a good condition for the predicate? Obviously, if I write a template library and a template function I need to try and be as accommodating to many different types of arguments that I will be instantiated with. And I need to think about ways to make my code as inclusive as possible and as accommodating as possible to users. And I think one aspect of that is trying to build what might be sort of like escape hatches or ways for whoever uses my library to give me a little bit of guidance of what they think the pass-by-value trait or pass-by-value semantics of their class should be. And again, on tomorrow's talk on Core CPP, I will discuss a little bit deeper that notion as well. The third thing that came to mind for me was the fact that function foo need to be implemented twice in this case. And actually, if you look at the slide from Herb of CPP, there's also a third implementation, and it seems like it needs to have a copy-paste of the entire algorithm in here. It's not trivial to take these two blocks of code and put them in a function and have these functions called that function, because we'll get into a recursive issue here, right? Does that other function accept things by const reference or by value? So this is the tricky stuff, and I think that by itself it makes this whole notion really hard to deal with. And lastly, there's this whole notion of aliasing that is really not addressed at all with this approach. You know, talking about a single function that accepts a single argument, it makes sense to not think about aliasing, but as soon as we start working with several functions or methods to objects, aliasing comes into play, and one might think, how should a template function accommodate that and give some control or some ability to deal with the cases of potential aliasing. So here we are close to the end of the talk, where I can present my potential approach to this issue, where I actually move away from concepts and move away from CPP 14 and basically try to use STD conditional and the STD ref or reference wrapper to have one implementation that chooses in compile time whether to take a reference or take a copy. Okay, so let's look at it a little deeper. Should pass by value v is the exact same predicate that Herb Sutter showed us on CPPCon, and the copy ref is basically a type def or using declaration that is either the type T itself or a reference wrapper for T. Okay, this use of STDK, I have to tell you, I don't know really why I wrote it. I think it might be better to have this decay, maybe not. I'm happy to hear your comments about it. And anyway, the choice between either taking the exact type T or a reference is done based on this Boolean condition of the should pass by value V that we've seen before, related to whether T is cheaply copied or not, as well as some Boolean escape hatch that tries to force a copy if you want. And using this construct, I can go and write my own template algorithm called apply, where I just I take my argument always as a constant reference, but after I took it as a constant reference, I basically choose whether to then do a by value copy into V or just another copy by reference into the STD reference wrapper. And once we have that argument V, we can go and work with it and do whatever you like. Okay, the force by value Boolean argument here can be used to deal with aliasing. Okay, so if my caller is concerned about aliasing and wants to make sure that a different object is called, they can pass this true argument here as well. Potentially, in case the container is contiguous or something, we can also try and help a user as well. And a part of that, we can use Herb Sutter's should pass by value V predicate to decide whether to do a copy and thus gain all the simplicity and performance and safety that's mentioned in the core guideline, or keep things by reference and avoid the cost of this copy. So this is my suggestion. I'll be happy to hear what you think about it. So to summarize, argument passing is indeed hard in C++ the way it is right now. Concepts make it easier to capture nuances and to have various implementations or various competing implementations and letting the compiler choose between them, but things are still hard. Aliasing is something that people don't think about often, but they can cause rare bugs, and more importantly, they can cause frequent performance losses. So if you have functions that accept references, keep in mind that even if there is no aliasing, you might suffer from performance losses because the compiler needs to protect itself from the risk of aliasing. I should say, by the way, that the C language has added a keyword called restrict that lets the developer tell the compiler regarding aliasing or not. And I think that at some point there's a good chance that C++ will get such mechanisms by itself. And last but not least, a little bit of a shameless plug for tomorrow's core CPP talk, where I will talk much more in depth about concepts. It's a longer talk. It has actually very little overlap with this talk. So I think if you enjoyed this, or if you have some free time tomorrow, you're more than welcome. I think we'll have a good time. So thanks a lot. I'll be happy to take any more questions right now. And obviously, happy holidays and New Year.
Well, thank you, Roi, and thank you on behalf of everyone for an excellent talk. We did have actually quite a few questions come in just towards the end there, so I'll just try and get through them. But the first one, I'm not quite sure what it related to. I think it was around maybe slide 10 or 11. We can go back to that, see if we can fit it in. Would the implementation be a copy and paste then? Or is this slide?
Yeah, I would think it would. Yeah, I think it would. I should say that Herb Sutter's talk was mostly about how things actually are complicated right now and how he intends to simplify things. So we didn't really try to make this approach, as simple as possible, because I think he had a horse in the game. He wanted to show how today's situation is horrible, and his suggestion is very, very good. But I would think that the copy paste is the approach that he would suggest for this.
Right, thank you. The next one was in relation to a bit later, but why reference wrapper instead of const ref? I think that was.
Yeah, so that's a good question. I think that's a good question. Yeah, okay, so I think
they're all good questions, by the way.
Yeah, I'm not sure. I wanted to make sure that I have an object that has like value semantics, but yeah, it's a great question. Potentially it can work.
Okay, something to think about for the next version.
Yeah.
All right. Then there are many problems with the is trivially X, where X is a stand-in, and they require compiler magic. Do you know if the standards people are considering fixing this?
So I agree with the claim that there are problems with is trivially X, and I actually talk a little bit about that more in the talk laid out for tomorrow. I do not know of any specific plans. The issue is that these things are meant to be very, very simple for compilers to reason about and to work with. And there's also, I think, binary compatibility stuff that make it hard for changing these. But I'm not sure.
So, the question is trivially fixable?
Yeah, likely.
And one more question, so far at least. Seems like this would all be made easier if targs at the call site didn't bind explicitly to t reference arg in functions. For example, in Rust, you have to write $x to pass by refs. Any thoughts on this?
Mm-hmm.
So I think it's an implicit reference when you pass it in.
Yeah, I'm not sure exactly about the exact question, but I think it has to do sort of like with this std : ref thing, okay? Because one could think that maybe all functions or all template functions should take things by value, and whoever calls them should use the std : ref to specifically say that they want a reference to be passed or something like that. I think that there is some merit to this claim or to this suggestion, but either way, I would usually expect a library writer to be more proficient than a library user, and thus I would like the library writers and the function writers to have a little more responsibility and have a simple user just have good defaults. So if I have a function, I would like it to use either by value or by reference with a good default and give the users some way to override it, but not much more. So that's my take.
Makes sense. Thank you. Yeah, and I think if I understood the question right, that would involve changing the language in a backwards breaking, very backwards incompatible way. So yeah, maybe Rust is your best bet if that's really what you want. That's all the questions. So thank you for that. Say excellent talk and great plug for tomorrow's say more of a follow-on version then rather than a bigger version. So that's it, core C++. Did you say?
Yeah, core C++.
Yeah,
they really meet up. I think, I can put the link to this talk slides on Remo later on, and where you can see all the links to Godbolt, etc., and also this one.